Hello and welcome to 3D Printing in Education by Pathfinder Learning. In today's episode, we'll discuss how 3D printers are beginning to help educators in areas such as math, science, and civics begin to create their own classroom manipulatives. We'll begin by looking at Thingiverse, a website created for individuals to upload solid models to share freely with others. This page shows the many math manipulatives that have already been designed. Users can either download and print the items as they are, or can upload the files to their favorite solid modeling programs to make their own custom modifications. Recently, MakerBot, the host of Thingiverse, held a contest for educators and designers to create and upload their math manipulative designs. Many exciting designs were created during this month-long challenge. Designs ranged from a scale for performing math operations, a twisting math factoid, and a gear set which I recently printed. After downloading the files for free, I was able to print a finished product at a fraction of the price I would pay to retail distributors. This finished set will definitely come in useful for my upcoming lessons on ratios. Students can change out gears with 8, 16, 24, and 32 teeth for a variety of mathematical conversions. The next exciting site for manipulative STL files is africanfossils.org. The site was created by Louise Leakey of the Leakey family, who has been working for decades in the Rift Valley of Kenya to unearth a tremendous collection of human fossils. In an effort to share this work, they have begun scanning their collection. This site allows you to view the ancient skulls from virtually any angle with the capability of zooming in for closer inspection of detail and structure. Visitors are then able to download the STL file for 3D printing. A tangible set of the evolutionary phases of the human skull could be a welcomed addition in evolutionary biology classrooms. The Smithsonian has also been busy in scanning many of their artifacts to share with the 3D printing community. Smithsonian X3D is a site that has a collection of many of the Institute's more well-known items. Visitors are able to take virtual tours of each item while having full control of the object in 3D space. This particular model is of the blue crab. Biology students could make observations of these high-definition scans while learning about its anatomy and habitat, which is described in the side panels. Within the Smithsonian collection, students can also have access to a high-definition scan of Abraham Lincoln's life mask casting taken in 1865. After close virtual inspection, history students can download the file and print a physical model which can be scaled to a variety of sizes to display in their classroom. The next step in this process would be for teachers and students to begin creating their own custom manipulatives. This site called Tinkercad is a free solid modeling web-based application that is very easy to use. Students are quick to learn the controls to modify the parameters from a large bank of primitive shapes. Height, width, and length of the objects can easily be adjusted. They can also be rotated, lifted, lowered, and joined with other shapes to create more complicated figures. Lessons can involve challenging students to create 3D shapes while staying within specified dimensions. When the designing is finished, the user can download the file called an STL that is used by the 3D printer. Allowing the students to run the software for the printer gives them the opportunity to learn about the process of slicing the model into two-dimensional shapes, which the printer then uses to create the hundreds of layers that go into making the objects. Students are often very interested in observing the paths the printer makes as a result of the algorithms which go into making each layer. As the students actively watch the printing process, they are better able to understand the limitations of the printer. This then translates into better design decisions. Objects with severe overhangs may require creative dissection to allow the design to lay flat on the print bed. By adhering to design restrictions, students get a taste of the same constraints professional engineers face. Students get definite feedback when they are able to physically hold and inspect the figures they created using computer software. Here is a list of the sites mentioned today. I have also included Umagine, which, like Thingiverse, is a free and open repository of design files to download for 3D printing. The following is a list of free solid modeling programs. OpenSCAD is a parametric modeling software which is best suited for more advanced students. Tinkercad is very easy to use and could be used in classrooms ranging from 3rd to 12th grades. Finally, Blender is a very full-featured 3D design software which would work well for older students serious about design. Be sure to check in with pathfinderlearning.org and my YouTube channel to see more videos and tutorials on progressive applications of the latest technology in K-12 classrooms.